Hello everybody, today we are going to continue on with variations and talk about inverse variations. The still unit 4, all that fun stuff. Something to keep in mind when you're doing variations is that direct and inverse look very, very similar to each other, formula-wise. Okay? Graphically, and they look very different. But formula-wise, they're very similar, so just keep in mind that it's very easy to confuse. So you want to put forth a little bit extra effort to making sure they don't get confused. So moving on, inverse. I'm going to move this guy over here because it's annoying. Inverse, oh gosh, I made it very large. Inverse variation is an equation of the form y equals k over x, where x does not equal 0, because if k was 0, then y would just equal 0, which doesn't help us. With the constant of variation being k. It's very, very large. Anyway, I don't know why I made the text this big. So, this is what the inverse variation graph looks like. It's curving around the axis. It's not actually going to ever cross it, it just goes around it. So this is an example. The standard says that you have to be able to identify an inverse variation on a graph. So you should be able to see a graph that looks like this and be like, oh, that's inverse. Okay? You don't have to worry about trying to create this from a graph at all. So this is just being able to like see a graph, knowing it's inverse right away. You don't have to worry about writing the equation for it, just it's an inverse variation. Okay? So the inverse variation formula, again, just so you know, is y equals k over x. So again, it's very similar to direct, but this is k over the x. To find the k, which we're doing the same thing like direct, where we needed k to be a number. So, but to get k by itself here, we multiply both sides by x, so to find k, you just do x times y. They're all very similar to each other. If you know this one, though, the actual inverse variation formula, you're fine. Like, you have enough to know that you can change it to get k by itself. Or you can plug stuff in and find out what k is. So I would just memorize that if you're worried that this is going to get very muddled in your brain, which would be my worry. Okay? So example 1, identify if it's direct, inverse, or neither. Okay, so we're going to do A together, and you guys are going to do B and C on your own. So in order to figure it out, again, we still need y to be by itself for both direct and inverse. So we have to get y by itself. So the very first thing we're going to do for A is subtract 2x from both sides. So now I get 3y equals negative 2x plus 5. I divide everything by 3, so I get the equation y equals negative 2/3 x plus 5/3. Well, solely because we have this plus 5/3 part, it's neither, because we shouldn't. In an inverse variation, it doesn't cross the y-axis, so there's no y-intercept. With a direct variation, the y-intercept is 0, so adding it on to the end doesn't seem helpful. So this one's neither. So B and C, you're going to get y by itself on both sides, and then figure out if it's direct, inverse, or neither. Okay? So go ahead and try those on your own, and we will talk about these during class. If you have questions, remember to circle it, put a star next to it, write your question down, like, why am I doing this? Stuff like that. Okay? Alright, example 2 is with tables, so again, I'm going to do A with you, and then you guys are going to do B and C on your own. Sorry, the tables are very, very janky. So, now with the table, when we're trying to figure out if it's direct or inverse, like I said before, direct variation has a very specific relationship between the x and y of each ordered pair, and it's going to be the same kind. So and that relationship is really k. For direct, we do y over x. For inverse, it's the same thing. They have a very specific relationship, but their relationship, their k, is x times y. So you should be getting the same number. So to do this for a table, what you need to do is actually pick one to test to see if you get the same K for it. If not, move on to the other one, see if you get the same K for it. If it doesn't work for either, it's neither then. Okay, so here we go. I'm going to start with direct. So that means I'm going to do y over x. So I'm going to do 1/2 divided by 4 gives me 1/8. 1/3 divided by 6 gives me 1/18. So because I don't get the same thing, it's not direct because I don't have the same K for each one. So now I'm going to go ahead and try inverse. So this time I'm going to multiply x times y. So 4 times 1/2 gives me 2. 6 times 1/3 gives me 2. So far it's okay. And 8 times 1/4 gives me 2. So because all the k's are the same, it's inverse. Okay? So you're going to try B and C on your own. You should be putting forth the same kind of effort. By the way, for A, the actual equation would be y equals 2 over x. Just thought you would like to know. So you should go ahead and try this on your own. Same kind of effort. You pick one. Maybe you'll get lucky and that'll actually be the one that it is. If not, you try the other one. It's like basically you're eliminating answer choices. Okay? And if you want to go the extra step, try to write the equation like I did. Okay? We'll go over these in class. Have questions, write them down. And the last one, oh, this is fun. This was actually one that was on your e-cart, but we decided to take it off, so now it's here. This is the real world, oh, I can't even say it. Real world word problems. Okay? So the volume V of a gas varies inversely as the pressure P put on it. If the volume is 240 centimeters cubed under pressure of 30 kilograms per centimeter squared, a lot of weird units in here, what pressure has to be applied to have a volume of 160 centimeters cubed? Well, let's start at the very beginning. They did not give me an X or a Y. Okay? So I have to figure out which one depends on the other. Does the volume depend on the pressure that it's put under, or does the pressure depend on what the volume is? Well, actually, the volume is going to be the one that's depending on how much pressure it is. Like the more pressure you put on, it looks like you want to know how much pressure is on it to figure out how much volume it is. Okay, I'm going to pretend like I can tell you what happens. So, and the pressure is your X. So, and what's really nice is that they tend to put it like Y varies directly, Y varies inversely. So they always put the Y first. So pressure is your X, volume is your Y. And then they told you it varies inversely. So you know it's going to be an inverse variation, so you're using this kind of formula. You also know that you need a number for K. So we have to figure that out. So I'm just going to translate it into the variables they have. And I still need a number for K. Now, that sucks because they didn't tell me. But, good thing, they did tell me a volume that you get when you put this kind of pressure on it. So that's basically my ordered pair. When V equals 240, P is 30. So I'm going to plug that into here and find out what my K is. So 240 goes in for V, 30 goes in for P. I now need to get K by itself, so what I do is I multiply both sides by 30. So I get K equals 7,200. Yeah, 7,200. Yes, it's a very large number, but real world doesn't mean that it's always going to be pretty. Okay? So I have my very large numbers. Now I can write my equation. So my equation now is V equals 7,200 over P. Well, they're asking me what the pressure is, so what P is, when I have a volume of 160. So they gave me the volume, and I need to solve for P. Here's the issue though. P is in the denominator. I need to get it out of the denominator, so I'm going to multiply both sides by P. So I get 160 P equals 7,200. Divide everything by 160. you get P equals 45 kilograms per cubic, or per centimeter squared. And I used the unit they had for pressure as well. I know, it's very wordy. Okay, now you know why we eliminated it from an assessment. Just did it as practice. Alright, so this last one, you're going to try on your own. I didn't make it as wordy. You're welcome. So you need to find out what x is when y is 8 and all this stuff is happening. Okay? So go ahead and try this one on your own. We will go over it in class. If you have any other general questions about inverse, write them down. I would make some kind of, like, I don't know, some kind of thing that will help you remember that what direct looks like and what inverse looks like as equations, because they are kind of confusing. So make sure you practice knowing which one's which. Okay? And we'll do that in class as well. But anyway, I will see you next class. Have a good day. Goodbye.